All right. Hello, everyone. My name is Hongchan Choi. I'm from Google Chrome team. I work with Raymond. I mostly work on the Web Audio API implementation in Chrome, but I also really enjoy creating like web apps based on Web Audio API and Web Media API. So this is one of my recent effort on the spatial audio on the web. But I think the topic of this talk would be like how to make the most out of the Web Audio API to create this spatial audio effect without introducing new specification and new native whatever. So this was the problem that was in our hand in Chrome team engineers. So we talked about how to bring this spatial audio inside of Chrome. And there was a lot of discussion. And it boils down to like two patterns, actually, in terms of specializing audio. The first solution was object-based spatialization. I think Mike will get to that in like more like futuristic perspective. But we already have that feature. I would say it's a little bit basic, but we already have this feature in Web Audio API, and Raymond discussed already. We have something called panel node and audio listener and audio context. So actually you can map your 3D object with this 3D panel node, and it will be like magically work. Actually, it sounds pretty good. And here's a demo, and Brandon I built a while ago. Okay. So here, actually, we have 3 sound sources in the space. It's really hard to hear the spatialization effect because I can control the volume, but yeah. The thing is, this specialization is based on HRTF. HRTF is kind of like specifically optimized for the binaural situation. So you have to use headphone or earbud to get the most out of it. Okay, but so I suggest you try this demo in your personal environment, like headphone or earbud. Then the next topic was next proposal was using ambisonics and binaural rendering. This actually got recently picked up by the VR community because it has a lot of benefit. It basically using ambisonic, some audio format called ambisonics, and ambisonic is pretty portable, I would say, because once it's encoded using this ambisonic microphone, actually the encoded media is basically decoder agnostic. You can play through any kind of arbitrary speaker setup. So that's where this binaural rendering comes in. So we use virtual speakers rather than like actual speaker array to have some virtual speakers around your head, and eventually we mix all the output from virtual speakers down into the stereo stream, which has this spatialness sense into it. But unfortunately, we didn't have that in our Web Audio API's feature palette, so that was a problem. The thing is, so now we know what to implement, what to have in our Web Audio API. But the thing is, this web platform is huge, and there are so many development path for this feature. So we had a lot of proposals. So this was obvious, and for the first one, using the extending audio and video element, and just to make that element aware of this spatially encoded audio, and somehow magically it will render all the audio into your headphones. And from my short experience writing spec, auto magical thing always backfires. So I think eventually we might have to consider this as a kind of introducing native implementation in the web audio rendering session to get the performance gain. But I think this was too far-fetched solution, and if we have to wait this to happen, I think we will lose our momentum to bring this spatial audio to the web. So we decided not to go this way. And the next proposal was creating new native audio node called like media stream spatial audio node. So you create audio element and pass that ambisonic audio stream into the media stream spatial audio node. It will just do all the spatialization for you. This seems like a very portable and quite module isolated implementation, but it has also its some perks. I think it's quirks. Because in order to render the audio stream into the binaural format, you have to have some sort of HRTF and HR impulse response, but actually it characterizes the sound quality of that. But I'm not sure that can be part of the spec or not, because it's quite subjective matter. So I think eventually our working group will move forward to this direction, but we haven't settled on any detail. And I think it's going to be a good topic for version 2 of Web Audio Spec. So I was just, I couldn't do anything, so I had to do something. So I started with the prototyping of this project with this, something called script processing node, which is deprecated per spec. I had to use this because I wanted to explore and measure the performance of the JavaScript-based audio processing first. And I actually made it work with the collaboration of Daydream audio team in Google. And it worked, but it came with a lot of like drawbacks, like latency, glitches. So it's not like production ready stuff. So I just went through my note, why can we make this better? And somehow I realized we have all the components that we need to implement this ambisonic stuff. Because when I look at the design diagram, actually, it is a concoction of filters and gain nodes and convolution. We already have those elements in the Web Audio API. So I started to implement this specialization with this native audio node, and it worked actually great. That's why we came up with the project called Omnitone. And obviously, TechCrunch really liked our idea. So we didn't introduce any native implementation. That means any browser has Web Audio API can run this spatial audio effect. So nobody had to wait, and it's already available. It's in here. So it came with, I created 2 demos based on this specialization technique. So I suggest you to go ahead and try it out with your headphone or earbuds. But what I want to talk about actually is the issues or experiences that I learned from this project. So this is something we're missing in our spec or in our web environment. The first one was the compressed audio format for FOA, HOA, multi-channel audio stream. I think Opus actually tackled this issue, and we recently landed on this ambisonic compression with the Opus codec, thanks to Jamieson team. And I think the ambisonic and object-based specialization is not the everything we have, right? So we certainly have alternative specialized technique, and we also need to talk about the native implementation for the future proof solution. And also something I really like to mention is now we have a separate render path for video and audio. The video goes to the WebGL path, and audio will goes to web. So in deep down there, we really don't have any mechanism for synchronization between those two. So this, I think, might something we have to talk about throughout the discussion on the floor. That's all I have to say. Thank you so much.